really glad to be here. It was a fantastic previous session. Really looking forward to the next session as well. As per the introduction, I've been doing automation for the last 25 years. So, I'm very easy to connect to. Literally go to linkedin.com/in/automation. It's the easiest username you can possibly get. So do feel free to reach out to me. This content is brand new, so no one else has seen this. So I'm quite excited to kind of go through the material today around generative AI. I know there's been a lot of speculation about what generative AI is, but yeah, let me kind of talk a little bit about where we've come from and where we're going. I literally have just been chatting with Diego von Forrester, and I'm speaking at Gartner next week, and I was just chatting with the Gartner analyst for the automation landscape. And, part of it was this kind of question around, well, everything seems to be happening so fast at the moment. Obviously, generative AI is just another step in that kind of evolution, shall we say. But, typically I would be talking about, Turing, and I know Diego's very much in talking about Turing bots when it comes to generative AI. And it was kind of this, okay, well, where are we going? What direction are we moving to? Why is AI such a big component now? And also, why is generative AI, token to be kind of potentially reducing our work effort by 50%? This does change depending on what you read. McKinsey's here. Goldman Sachs says about 35% of all our work activities will be automated by 2025. The last Q&A session, when they were talking about things like JMeter or Taurus, you can get generative AI all ready to write those kind of languages. Well, what is it next? What's its limitations? Where is it going? And I want to share some of that insight based on kind of what we've been doing for the last year, really. So we kind of started looking at large language models, and we've been applying various different use cases with our customers. So today I'm going to share you some of those stories. You might have noticed at the start there was also Web 3.0 thrown into the title, which is funny because I'm flying to Vegas on Friday, and then I'm speaking at Gartner, and then I'm flying to Rotterdam, and then I'm flying to Barcelona, and then I'm flying to Madrid. And the Madrid one, they kind of said, well, can you remove Web 3.0 because we don't really understand what it means. And so, when I talk about kind of Web 3.0 technologies, I'm really talking about WFT. So what's the future? This is the underlying technology that's going to change the face of the planet. And of course, today we're just talking about large language models in essence. But things like NLP, things like chatbots have been around for many years. This isn't anything new. And for those who kind of follow kind of what I've been doing, I've been really focused around things like augmented reality and mixed reality and virtual reality last year, really about kind of where is that going from a metaverse perspective. And it's actually quite nice to get back to, I'm going to say grassroots, but, foundational components of technologies that we can consume today. And so Web3, for those who've already probably quite familiar with it, is really this kind of viewpoint of building on the foundations of Web 1 and 2. So, the desktop browser. So we're talking a lot on the last session around, testing in SaaS. So, this move from client server, I suppose, to cloud computing, and then testing against cloud computing is kind of Web 2.0. And then we move into distributed computing. We've all probably heard of the decentralized internet. So what does that mean for testing? And then some of these new technologies, such as generative AI, and they're the ones that I will be focusing on today. But when I kind of look at 3.0, I talk about kind of opportunity, because really this means something different to depending on the customer you're working with, or what the industry vertical that you're in. I think there's a lot of exciting opportunity here. And I literally did just come back from Silicon Valley a couple of weeks back, And I was doing a talk there and around kind of some of the conversations I'd had with Steve Wozniak, and this viewpoint of Web 1, what should have the internet been? It was a place to share resources and share learnings and educational. And I think part of it is the stats just hit that we spend 50% of our spare time using the internet. Is it really that in its current form, everything that we expect it to be? And I really do think the realization of Web3 is going to answer some of those problems that potentially need to be resolved. So, I'm very excited about kind of the shift towards these technologies. But let's get on to kind of the generative AI. And of course, you'll all be very familiar with the term GPT, and you most likely will associate that with ChatGPT, and that is definitely a good place to start. But really, when we're talking GPT, we're talking about generative pre-trained transformers, right? And OpenAI is one of many which have done this. Of course, there's bigger models like Palm, that's kind of trained on a 540 billion compared to 175 billion for ChatGPT 3.5 in essence, falls slightly more, but not that much more. And we've seen some of the success, right? And we've seen some of the catastrophic failures. Definitely Google's launch wasn't as they expected. We've seen Microsoft really just go from strength to strength. I'm using the latest Microsoft Mesh and Teams, and bringing it all together, and it's building in some of that kind of co-pilot capabilities, and it really is quite intuitive. And you can see, obviously, Google have done the same with their G Suite kind of products. You can see this being commoditized very quickly, and in essence, you won't really know what's a GPT and what's not, what's kind of, the differentiator. It'll just be commoditized. But we've also probably heard a whole stack of contradictory views as well, or fake news, depending on people's viewpoints of, trustworthy and etc. But it's good to know the foundational information before making those kind of large kind of decisions. So I was just chatting to one of my R&D guys who's based out in the States, and I was kind of saying to him, I'll put something in from your collection. And we use ChatGPT occasionally when we want to kind of stop using ChatGPT too much. But there's a lot of GPTs, and I think what we're going to see, and my kind of prediction really, is this year is going to be legislation. It's going to be compliance, regulatory, things like the EU AI Act, which I'll be talking about later on. It's going to be a lot more about where's the IP, what should I be talking about, what should I share with a large language model. And then there'll be a lot of kind of spin-offs like ChatGPT, but testers GPT, model GPT, developer GPT, insurance GPT. We're going to get pretty much everything. But what I've tried to do is I've added in the corner what these platforms actually are, so you can kind of cross-reference those to a larger list. But yeah, back in December, as you can kind of see on the date here, December the 20th, Randy was putting this together, and it was kind of great. You call the API will come back with a response. You send it some text, you ask it to, write a Gherkin script, you ask it to write some Selenium code or some JMeter stuff. Of course, it will come back with a response. It's, we've all played with it, we've all used it, we've all seen the opportunities and some of the maybe misuses of it. And, I think there's definitely something there for an opportunity to build testing use cases on it. So like I said, these are the technologies, the ones that I've highlighted in green, which we'll probably go through, I think, most of them today. But the stuff on the left-hand side is the capabilities. So what you're seeing on the right-hand side is something I did at one of our partners did at Mobile World Congress. And this is me using the brain to input. So literally being able to take low frequency waveforms coming from the brain, and then you to convert those into inputs. So, as much as some of this stuff down at the bottom, like brain to input, seems like it's a million miles away, and people like Elon are stuck with Neuralink and a few other startups, there is still kind of some really interesting ways of how this will potentially change the way we interact from a human-computer interaction perspective. So I'm going to kind of run through the ones that we've been using, the ones I'm going to show you a little bit. So it's a text to image, which is really useful. We've done it for a number of clients who need, images or training data or kind of components. The other one is, which is kind of, I realize is in the wrong place there and I can move it, thankfully, is alpaca. So we saw quite quickly, especially with the legislation kind of challenges that, people were having to bring their own large language model. And that's kind of where we've got to now, is we kind of had to build your own inside your own private network instead of having a public one, which kind of gets rid of the IP concerns. Alpaca was the first kind of MIT deployment of a large language model that you could deploy within your own, data center, I suppose. Runway I'm using quite a lot at the moment with text to video. I'm going to show you some fun stuff with that later on. Google AI is incredibly capable, and we're using it pretty much on a daily basis. The same goes to the Microsoft AI, which I kind of really need to highlight a little bit more on this one because it's not on the list, but the compute custom vision by Microsoft and really all the rest of the cognitive services are fantastic and they're incredibly easy to consume. Using things like Resemble and Descript for text to audio generation. I'll show a few use cases of how we're doing it there. Of course, OpenAI and GPT-4. We're still waiting on the visual GPT component, which will be game changing for testing because it will be able to look at the screen and then say, as an accessibility tester, tell me what I should be looking for. And, if that W3C accessibility kind of standards isn't your kind of normal patterns, you're going to be able to kind of take advantage of the trained models. Of course, GitHub Copilot for writing code. I'm doing a lot with Mojo at the moment, which is, really, really powerful. Auto GPT, which again, I'll show you, which then kind of scales GPT to be able to sort of support out, in essence, what you've got is short-term memory of a thread of what you're asking the GPT, and then Auto GPT correlates that. So you can say a large task like write me a software product or, create me a mobile app, and it will go off and publish it into the App Store, do all the hard work of setting up credentials and use multiple threads to go off and solve that problem. We use Dolly now as our kind of capability in-house as we build our own capabilities. But then there's things like, visual chat GPT, which makes a massive difference. So, I obviously give a nod to my friend Jason. We've talked a lot about this stuff over the last probably 2-3 years. Jason and Tarek King, really have kind of been leading the way for test.ai for many years now. Jason spun up testers.ai, and that's the persona-based way of testing. And I'm sure you've all seen this thread around, ChatGPT, and this was 3.5, I think it was, being fed the ISTQB board questions. I know the next speaker actually did their ISTQB with the BCS, which I'm on the committee for software testing at the moment. And so, the question is, can it just be a software tester? And I think this brought up some kind of queries about, of course, it's going to answer questions right, but it's also going to answer questions wrong, right? So yes, it scored 77.5, but does that make it a tester? And, I've literally just come off a webinar with my friend and colleague, Paul Gerard, who's been talking about this for many years. And, what testers do, and this is why a lot of what I'm going to be talking about today is talking about, I'm going to call it tester in the loop now, but, it's human in the loop driven. It's not going to be any point where it's going to just autonomously remove you. So even though that's the next session that I'm doing in 35 minutes. So let me kind of give you that bit of journey. And, last week I did a session with Diego from Forrester, which will be going live in a few weeks' time on generative AI, or what he refers to as Turing bots, which are in essence a nod to Alan Turing, who actually lived and died a few miles from where I am at the moment in Bletchley Park, which you probably all heard of before. I need to find a higher quality version of this. But my friend Paul, who I mentioned, kind of wrote this, which is why it's so blocky, probably about 10, 15 years ago, about the fact that, we can utilize modeling as a way of understanding systems of under test or systems of knowledge or sources of knowledge, and create a model of the system and test that model. As humans, we're very visual, and understanding models is kind of core foundation to kind of, if you are interested in model-based testing or not, there's different camps on that. But I'm going to talk a little bit about how you can utilize modeling, and I'm going to take you through this journey a little bit today. So when I was sat with Diego, I kind of talked to him about kind of, okay, yes, you're going to see the Turing bots at pretty much every stage in the life cycle, right? You're going to see them as testers, you're going to see them as coders, you're going to see them as operational capabilities for open telemetry and testing. It's really going to kind of be augmenting testing at various locations within the software development lifecycle. So yes, we're going to see these, in essence, narrow GPT implementations, which people will consume very much in the way we consume GitHub repositories for different capabilities that we're looking at, whether we're doing API testing or UI testing or something else. So kind of moving that away, and I did this slide this morning just because I wanted to add something reassuringly complex to my slides for next week at Gartner. But the way we've been kind of doing it, and I think I mentioned this at the start, is, it's very much reliant on humans in the loop. And that was kind of the feedback from the last webinar that I did about an hour ago, where a lot of people were kind of saying, well, is this the age-old question around, testers? The testing industry is dead? And the answer is no. It's just you're learning different skills. You've got to learn how to humanly interact with computers better. It's the same skill that we've had many years. We're just pivoting it. And it's a cognitive skill, and cognitive reasoning skill, which you have to kind of be able to understand and maybe talk to it in a different format. I'm actually putting together some material on a webinar that we're hopefully running in Portland at the end of the year, around how do you speak to AIs, shall we say, for a second as a tester. But yeah, so kind of there's a few things that are interesting in this landscape. The first one is, like I said, is human has to be in the loop all the way across it. So when we create a model or we think about a model of a system, we understand some requirements and we do the planning, that needs to be a human-based activity. Yes, it can generate code, unit tests, data, security tests, whatever, security coding, whatever. It can then run those and execute them and make a decision. Again, someone needs to make a decision of whether we go or no go. And then it can, it can monitor, it can learn and feedback this all across from a shift-right perspective. It can learn the systems of systems and dependencies. It can learn large language models trained on your internal sources of knowledge. So if you've got a particular special source that you do within your organization, it can replicate that and understand the rules of your braking system or your insurance system or whatever it may be to be able to inform how it tests the system. So incredibly complex slide, but it kind of tries to explain what and solve these challenges in software testing. Why, we're trying to go off, and like the last session, we're trying to look at TAS solutions to talk about addressing testing in the cloud, UI, API, performance, security, whatever else it is. We're looking at individual solutions. We're not looking at non-functional and functional levels of kind of, this system must be able to work at X scale and solve, put a level of assurance around it. Again, we're kind of relying on AI, which are sometimes not explainable and really kind of not sure, does that really solve the problem or does it not? And then, supporting this triangle of business, technical and developers, in the kind of the three amigas kind of perspective. So like I said, we're really looking at this about how we can leverage these different types of capabilities as part of the software development lifecycle. And the best, some of the material I was contributing to last year around automation fabric was all around how do you start utilizing this across your life cycle, and how do you provide and report that level of information to provide assurance, overall assurance of the systems that you're trying to test. And this is kind of where I'm working on now with my team around automated test assurance and building platforms very much like an APM would be, but for automated testing and testing in general. But let's go back to the use cases and let me show you a few kind of live demos of, well, not live demos, but some demos of it in the last 20 minutes. I kind of wanted to, and this is obviously a generated image of me, but part of it is I'm trying to work out the use cases, and I've been working with a lot of customers recently to kind of say, okay, is there use cases that we could potentially leverage for this kind of technology? And I think from an augmented testing perspective, there definitely is. The first thing we started with was this ability to generate requirements. So if we take the braking system example, right? If you've got a spec on how that's supposed to work, you can then teach your large language model to understand your domain. And then you can say to it, oh, write me some Gherkin syntax scripts, right? So we've all used executable specifications. We know they come from living documentation. So it learns it generates the Gherkin scripts. Great, we've got some Gherkin. We could, in theory, run those Gherkin if we were doing BDD, TDD, ATDD. But the next step really is we can say, okay, well, go off and build that application. So launch Copilot, create the application under test. So it pops up with the application, which does the system testing of that component. We can then ask it to generate automated tests to run those scenarios. We can get performance and security tests against that. And then when we can get it to deploy it to production and then actually start measuring what the usage is, the experience, et cetera, et cetera. And we can continuously, complete that loop. So let's start with the human in the loop. And I took Jason's example because I thought it was quite funny, because he's my friend Alan Page, who wrote the book on how Microsoft test, and I wrote a book behind me with him on experiences in test automation with Dorothy Graham many years ago. Jason kind of said, oh, is stock price a proxy for quality? And so I said, okay, well, what I'll do is I'll just ask ChatGPT. I'll say, oh, can you write me some Gherkin syntax to create some tests to test a stock system to check if the Microsoft stock level at the time being. Now, this is obviously really simple, but what I did is I generated obviously generated the Gherkin syntax, and then we auto-generated a model. And we talked about models previously, but out of the back of that model, it also created the Selenium scripts. It created the Postman scripts, which I know they were talking about in the Q&A session previously. And, you go and check out Paul's stuff, which he's done all this and, how to play with ChatGPT 4. But we took that model, which tests the test. It goes from, in essence, text to model. So it takes Gherkin, creates a model. The model changes. It updates the Gherkin. So it's still a complete loop. So if we think about test, requirement and code, it's still intact. Then we go off and just say, okay, write me a stock data application to check the stock for, Microsoft stock. So I'm literally going off it using Copilot, which is paid, unfortunately, but will generate you the code. Obviously, the only thing I've had to provide is the actual API key to go off. And then it's just using Panda data frames to dump out the stock price, right? Which is great. So I've now got my application and the test. I've got my requirements as we expect. I've got my automation code. So I've got my ability to write Selenium and check the stock price. I've got the ability to do an API call. And again, you pass in that API key to then test what the value is. And I can check API, database, UI, whatever. The next step is then to run it, right? Which is kind of okay, let's generate, let's take that, in essence, Selenium, which is auto-generated. Of course, it generates not the latest version of Selenium. So there's a slight change, which we've done within our application to say, pivot it, the Python script that it generates into something a bit more usable. We then go off and run that and launch the website and go and search for the Microsoft stock price, and then come back with the current stock price is $243, right? And we do an assertion, but in essence, that's the Python code which it generates from ChatGPT. So the next step is, okay, can we do more other capabilities that sit on top of that? And so the next step was, what else can we do? Can we do visual testing? And this was really the capability which I mentioned with the visual GPT, was could we, understand and recognize images on the screen? The answer is yes, we can understand and recognize and use computer vision. So in this particular example, which was really my last year's worth of talks, was, can I drive something like the HoloLens, which is behind me, and then run some testing on that? Of course, it's not a browser, it's actually an image, but within there, I'm searching for images, and then I'm validating within that three-dimensional space that it can see an image of a dog. And of course, this again is just basic computer vision capability that says dog, pug, plant, carnival, grass, whatever. And then I can pass in from a data-driven perspective, cat, dog, whatever else. I can run that infinitely to validate from a computer vision perspective. So this is the next step of capability. You've gone from text to, in essence, code. And the next step is, image to code, in essence. So you can, drive things by what you see on the screen. So this is the whole visual GPT of, I see a screen, how do I test that screen? Well, I understand the concept, therefore I can generate a model out of what I'm seeing on the screen. The next step is, well, really, how do I also then do it from a VR kind of perspective? So testing things like Microsoft Mesh, Meta Workspaces, what you see here, where I'm directly correlating the movement from a human to the movement up within a three-dimensional space and tracking that information, again, just using computer vision. The other example which I've got, which is a little bit further down the line, is actually around generation of actual images. So within here, we've just seen the Selenium demo, which was very cool. But the next thing is I might say, well, actually, I want to be able to generate some images to validate it against, right? So I've got, maybe I'm Google searching for two dogs on a beach. I can use things like DALL-E to then say to it, okay, I'm now going to generate pictures with that to validate against. So I can literally put into here some text, which is two dogs on a beach, and then it will literally generate me a whole stack of images based on DALL-E's generative AI capability, which if you've seen any kind of AI image or based video out of the back of it, the images that are coming back, which is going to open in a second, of course, are purely just generated by an AI, but we can then compare the two and say, oh, well, that one looks very much like the one that's running across on the beach. So we can validate, in essence, have some testing data to support that. The next bit, which is what I mentioned at the start, is Auto GPT. It's this ability to take advantage of long-term memory instead of just short-term thread memory of what you're getting from GPT. So you can solve a bigger problem. So you can say to it, go off, set me up an API key for this platform, deploy, give me a private key or a public key to deploy into, AWS, get a repository and push that repository and build the application under test. It needs a Google API key, so I'll go off and get that. So you could have multiple tools, in essence, multiple threads, all running simultaneously. So Auto GPT really allows you to kind of throw compute at it and then solve the problem. Other things, like I kind of showed a bit of the video around text. So this is for people who haven't seen it yet, but this is Microsoft Teams with Microsoft Mesh, which is combining this ability to then use gestures and understand movement. So obviously when I start talking, I'm just in a call at the moment with a whole stack of people from the Source Labs call, but you can see later on that actually as I start talking, it actually follows my lips. So it's actually synchronizing against my my actual input. So again, we can see how avatar creation would also be, an item that is utilizing this kind of text technology. And then you've got the ability to kind of take just your face and then actually overlay that into a 3D model and create an avatar with much more depth, which of course, again, uses a large amount of compute, but you can kind of see the advantages of having a more realistic and engaging version of or digital twin of yourself. So again, Visual GPT is really going to provide us capabilities beyond what we've got at the moment. Combining some of these technologies I kind of mentioned before about things like text to audio. So for certain things like the HoloLens, where we're not driving it by directions to click on things, we can actually say voice commands. So we can send it voice commands to launch things. This works with obviously phones and virtual personal assistants as well. So you can literally kind of say to it, "I'll launch YouTube, do this, navigate to this page." And we're generating those, in essence, voice recordings based on the text that we're inputting. So we're sending a text to do a command, it then launches it. And what you see within this demo is once it's launched, that command to it, it then drives the robotic arm as well to say, okay, let's move left, look right, look up, look down. And again, that kind of robotic process automation then allows it to move and run. And in this case, we're validating the battery of the actual device to see how it performs as we send it commands and we move the device around. So you can see the kind of bring it all together and bring the digital twin together of how you would test utilizing this technology. So kind of leaving a kind of an interesting one, which I kind of looked at the other day, just today, actually. And so this video, even though it seems to be slightly corrupt a little bit, it might be the bandwidth, but it's completely generated by AI. So literally someone's just inputted a story, the story's, is being played out. And as it's played out, it's generating the cats, the video, the people. These are all completely artificially and generated using Runway, which I would definitely recommend. Again, there's a free version of that. So you can literally tell it a story and it'll generate a video to go with it. So lots of great capabilities, very easy to consume, very kind of, I'm not going to call it low-hanging fruit, but very easy to kind of augment what you're doing already from a testing perspective. And I guess this then takes to the next step. It's like, it's not AI that's going to actually replace you. It's a person that's using AI that will, because it gives you all this additional capability. It gives the ability to do much more, be able to create OWASP ZAP tests when you're not a security engineer to help you do things that maybe isn't in your normal job specification by leveraging these different types of tools. However, I say that with a kind of a caveat on the end, is that we kind of know that these systems are very good at, in essence, memory retention, right? So it will pass an exam, it will pass the bar, it will pass a medical doctor, it'll outperform a medical doctor with a number of years of experience. And this is all proven. However, it's not as simple as that. Just because it can, do surgery and it can go into court and argue on your behalf, the question really is, and as many people like Michael, are saying, is, well, should it? Is there a trust issue about the quality of what you're getting out? And of course, we're not there yet. We're still on that journey. We're still very much trying to understand what the narrow use cases are, which add value, and what the logical things that you should leverage this kind of technology with, and which ones you shouldn't. And like I said before, building your own large language model, or at least hosting OpenAI on Azure or something like that, kind of augments kind of partially the problem, but still is, a question around IP and sharing stuff. So if I share proprietary documentation on requirements to ask it to create Gherkin syntax, where is that data being stored? How's that being managed? In a very much a GDPR kind of landscape. So kind of leaving into that, kind of opening the kind of questions up now, but There is a caveat, and this is why I said this year is very much going to be around legislation and regulation of the AI use cases and what you should and shouldn't be able to do. You know, as a medical doctor, maybe let's say 90 out of 100 times it diagnosed the right diagnosis. If an AI is doing the exact same thing and it does 92%, but it gets 8 wrong, potentially it could be, taken to court. It could be a large fine of about 6% of the company's turnover. So, this is a real challenge in the landscape.